welcome back to the university, and in this video we are gonna be talking about volcanoes. Alright, first and foremost we must have our objectives, and one of these objectives is to be able to identify the type of volcano according to their shape, and we should be able to identify the type of volcano according to their explosions, because some of them are exploding violently, and we should be able to identify the type of volcano according to their activity, because as you know, some of them are sleeping for a very long time, and the most important thing to be able to do is to identify the type of magma that is present inside the magma chamber. Basically about the chemical composition. We are talking about the chemistry. Alright, and be able to describe the physical appearance of every volcano. Are they short? Are they tall? Are they wide? How do they look like? And we should be able to analyze how volcanoes are formed. Where do they usually form? And are there any connection about volcanic formation, and is it related to plate tectonic theory? And we should be able to classify the debris according to size and phase. So these debris are from volcanic eruption, and we should be able to list the positive effects that we get from volcanic eruption. Since there are positive effects, I know that you can try to appreciate the importance of these positive effects. Of course, you know that there are negative effects that we get during a volcanic eruption or after a volcanic eruption, and hence we should be able to discuss some ways to minimize the risk and hazards brought by volcanic eruption. And basically the most important part as a student is to pass your quiz and pass your assignment. So let's start with the most important reasons why volcanoes have different characteristic. Basically, is due to the type of magma that feeds the magma chamber. So there are four types of magma. One is the basaltic magma that is most widely distributed. Alright, so it is determined by the amount of silicon dioxide content. In a basaltic lava, silicon dioxide ranges from 45% to 52%, and this is mainly composed of plagioclase, monoclase, pyroxene, and followed by some orthopyroxene, peridot, and amphibole. Alright, so have you ever come across with the word pyroxene? Because I am thinking that this is somehow related to the Pyrex brand that we use in cooking. Maybe this is the reason why it is so expensive. Let me know what you are thinking about this in the comment section below. So basalt is also characterized by its specific gravity, and it is 2.7 to 3.3 times more dense than water. So if you put it in a glass of water, it will sink. It has a porosity of 1.28. When we say porosity, it's the ability of water or of the material to absorb water because of the small pores. It is also resistant to weathering because it has high compressive strength. So it can withstand 3,000 kilograms per square centimeters of force per square centimeter. Next thing is we can classify a basalt into two categories. One is the tolite and the alkaline basalt. Alright, next is the chemical composition, which is the most important thing to understand. So there are chemical formulas right here, and this is the chemical name. Alright, first and foremost is the most abundant compound in a basaltic lava or in any type of lava. Alright, that is the silicon dioxide or SiO2, and it can range from 45 to around 70% depending on the type of lava. We also have the Al2O3 or the aluminum oxide. It has a average per percentage per mass of around 14.6 to 18.3%. It also contains calcium oxide, magnesium oxide, sodium oxide, and its relationship to potassium oxide. So this is very important because you can determine the type of lava that can be used for making gunpowders. Alright, so we also have titanium dioxide or oxide. We have ferrous oxide and we have ferric oxide, and the rest is very minimal, which is around 0.09 to 0.13% by mass. So the viscosity of the material is defined as the ability of the substance to resist flow, and this is related to the silica content. Meaning to say, the higher the silica content, the more viscous the lava will be. Alright, so we have four classification of or four types of magma according to their content of silica. Alright, so we have the basaltic lava, which I have been discussing, and it will create mild explosion, or the type of or the behavior of the explosion of volcanoes that has basaltic magma inside their magma chamber will be mildly explosive. So it has low viscosity, and it will form cinder and shield type volcano. Alright, so we have the next category or class sample, which is the andesitic magma. Will produce mildly explosive to highly explosive type of eruption. Alright, so the magma content or the silicon content of this type of magma is 55 to 60%. It will have medium to high viscosity. Alright, it will produce composite type of volcano and caldera. Alright, caldera is formed when the magma chamber totally collapsed and the volcano erupted. Alright, so the cone shape is gone, and the big depth of the caldera is being exposed. Alright, so meaning to say, it is very explosive. We have the dacite, that is non-explosive, that will produce non-explosive or otherwise known effusive type of eruption. But if they contain some gas, well, it will produce some composite volcano and some lava domes. Alright, so the amount of silica content in this kind of lava sample is 60 to 70%, and it has high viscosity. So materials cannot travel far from the vent of the volcano or from the crater of the volcano. So they will actually create some lava domes. So we have the last one, which is the rhyolite, which is very explosive. So this will create a type of reaction from highly explosive to extremely explosive due to the highest amount of silica content in them, which ranges from 70 to 77%. So you are gonna you're gonna expect the formation of lava domes and some caldera. Alright, so there are type of eruptions which is related to the mechanism of eruption. So what type of material they release. Alright, so we have the magmatic eruption, we have subcategory. So when we say magmatic, these are eruptions that have solid debris, only solid debris. Alright, we have the Hawaiian type of eruption, which is regarded to be the most calmest type of explosion, alright, or of eruption, and this is effusive. Alright, next is we have the Strombolian, which is accompanied by distinctive loud blast. Alright, so they are loud. And we have the Volcanian, they are also more explosive than the Strombolian counterparts, with eruptive columns often reaching between 5 to 10 kilometers. This is about ash. Alright. Lastly, Volcanian deposits are andesitic. So to the dacitic, and they are more of andesitic rather than basaltic. Alright, so we have the Piline eruption, and the only difference is that in Piline eruption, the volcano can withstand high pressure. Alright, so the pressure builds up until a certain limit and then explodes once. So one big time explosion is something like that. And we also have the Pilinian type of eruption. And the only difference is that the conduit of the volcano is so small. So when the volcano reaches, or the gases inside the volcano or under the magma or mix in the magma reaches a certain volume, it will explode at once. Alright, so the Mount Vesuvius is an example of a volcanic eruption under the category plain yan. Alright, so we have the Magmatic Eruption, meaning to say it actually has something to do with water because of the word rhea, which means water, meaning to say there is an interaction between lava and water, or magma and water. So there are three subcategories. We have the Surtsian, we have the submarine, and subglacial. Alright, so so meaning to say that it actually has something to do with the place where the eruption has occurred. Alright, so as a Surtsian or hydrovolcanic eruption is named after the famous eruption in the island of Surtsey, alright, in the coast of Iceland in 1963. Water is heated by lava and it flushes into steam. Meaning to say it superheated and then it violently erupts. Just like when you pour cold water in a hot rock, the rock will collapse. Something like that. And then in the submarine eruptions are type of volcanic eruptions that occur underwater. And then subglacial, these are eruptions that occur underneath the ice slab or a glacier. Alright, and then lastly, we have the phreatic eruption or phreatic explosion. So phreatic eruptions are a type of eruption driven by expansion of steam. So when cold groundwater or surface water come in contact with the magma or the lava, it superheats and explodes. And then it will be able to fracture the rock, and then it will try to thrust the mixture outward, composed of steam, water, ash, and some volcanic bombs. Alright, and volcanic blocks. So here are the example of the volcano according to their shape. Alright, we have the cinder volcano, so just like Hawaii. So that type of volcano is called cinder volcano. Alright, next is shield and lava domes. Basically, this is longer, alright, longer versions of cinder volcano. So we have the Mount Olympus Mons and Mauna Loa. Alright, so we also have the most violent, maybe, alright, category of volcano, which is the composite volcano. And you will see that it nearly has a perfect shape, perfect triangular shape or perfect cone shape. So just like the Mount Fuji and Mount Mayon. Alright, and it will form an andesite and dacite platform. So next is we also have Mount St. Helens as an example of composite volcano. We also have lava domes. Alright, and lastly we have caldera. Alright, so next is to classify the volcanic debris. Alright, we have the gas type, which is mainly composed of carbon dioxide and sulfur dioxide. Alright, and some other gases, maybe it's a mixture, but majority of the gases present in the volcanic eruption is mainly composed of these two. Alright, carbon dioxide or sulfur dioxide. And next category is vapor. Alright, steam. Alright, that is superheated to high temperature, and that is mainly composed of water. So after volcanic eruption, this will mix up, and then when it rains, the rain that it produces is a little bit acidic. So you should be able to avoid that. And then we have lava flow materials. Alright, we have the AA, we have the block, we have the lava flow, we have the pahoai-hoai, we have the pillow lava. So there are different types of lava, alright, or of rocks that are formed after a volcanic eruption. So it depends on the rate of cooling. Alright, if a lava suddenly cools because it is nearby a ice, so it will have a different kind of appearance. We also have pyroclastic materials. We have agglutinate, ash blocks, bombs, and flat crust bombs. So as I mentioned, they have different sizes, but all of them are solid. So you should avoid it because it can destroy your house. Alright, so other pyroclastic materials are cowpie bombs, fusiform bombs, irregular bombs, and then spherical bombs, cinders, lapilli, pumice, and then tephra. Alright, so these are the volcanic materials that you should avoid. So in the next part of our video, we're gonna be discussing the formation sites of volcano. Alright, so I hope you guys were able to learn something about this video. Thank you for watching the university, and if you like this video, give us a thumbs up and don't forget to subscribe. Click the subscribe button and hit the notification bell to get updated whenever I post new videos like this. Okay guys, thank you for watching and see you next time.